In this section of the CompTIA SecurityX certification course, we'll focus on the topic of security architecture, specifically on resilient system design. We'll start with an overview where we'll delve into the fundamentals of component placement and configuration within security architectures. This includes identifying key security devices, understanding their roles, and the significance of their deployment. Designing robust and secure network architectures is foundational to maintaining the integrity and security of an organization's systems. It involves meticulous planning and strategic placement of components to create a resilient infrastructure capable of withstanding various security threats. Grasping where and how to deploy these critical components effectively can make a significant difference in the overall security posture. Up next, we'll explore one of the cornerstone elements in security architecture: firewalls.
In this section, we're focusing on the placement and configuration of firewalls within your network architecture. A firewall acts as a critical barrier between your trusted internal network and untrusted external networks, such as the internet. It filters both incoming and outgoing traffic based on a predefined set of security rules, ensuring that only authorized communications are allowed through. There are two primary types of firewalls you need to consider. 1. Network firewall. These firewalls protect your entire network and are typically deployed at the perimeter, where your network meets the internet. They are designed to handle large volumes of traffic and filter it based on various criteria such as IP addresses, port numbers, and protocols. 2. Host-based firewalls. These are installed on individual hosts or devices within the network. They provide a more granular level of control by protecting the specific host from unauthorized access, monitoring the traffic to and from that host. To give a practical example, here are some commands you might use when configuring a firewall on a Unix-based system. Sudo UFW enable. This command enables the UFW, uncomplicated firewall, on your system. Sudo UFW allow 22. This allows traffic on port 22, typically used for SSH, through the firewall. By placing and configuring your firewalls appropriately, you can establish a robust security layer that significantly mitigates the risk from external threats, ensuring better resilience and protection for your network infrastructure.
Moving on, let's discuss the Intrusion Prevention System, or IPS. An IPS plays a crucial role in network security by monitoring traffic for any malicious activity and taking active steps to block or drop such threats. This proactive stance ensures that potential attacks are thwarted before they can cause harm. An IPS is deployed in line with your network traffic, meaning it analyzes the data as it flows through the network and can intervene directly if it detects something suspicious. For practical setup, configuring Snort as an IPS involves specific commands. For example, sudo snort-day console nic/snort-snort.conf -daq -daq-efvar sudo snort-devq sudo snort-devq -daq-var device-gr nic/snort-snort.conf. These commands enable Snort to actively inspect and take action on the network traffic, thereby enhancing your organization's security posture. An intrusion detection system, or IDS, serves a crucial role in network security. Its primary function is to monitor network traffic for suspicious activities. Unlike an IPS, an IDS simply alerts administrators to potentially malicious actions and does not block traffic. When deploying an IDS, it is typically set up to monitor a mirrored copy of the network traffic, allowing it to analyze data without impacting the flow of network communications. Popular tools for implementing IDS solutions include Snort and Suricata. Snort, for instance, can be configured as an IDS tool to passively scan and report on network activities, providing administrators with the alerts needed to address potential threats. Similarly, Suricata offers advanced monitoring and alert capabilities, ensuring comprehensive network visibility. In essence, while an IDS may not actively prevent threats, its ability to provide timely alerts is essential for maintaining network security and facilitating prompt responses to suspicious activities.
In this segment, we'll be focusing on vulnerability scanners, an essential component in network security. The primary role of these scanners is to identify security vulnerabilities within networks and systems. By detecting weaknesses, they help administrators prioritize and address potential security risks before they can be exploited. Two widely used tools for vulnerability scanning are Nessus and OpenVAS. These tools are known for their comprehensive scanning abilities and ease of use. For instance, to initiate a scan using OpenVAS, you would use the command openvas-start to start the service, followed by openvas CLI, scan target IP, to begin the scanning process on the specified target. Remember, employing these tools regularly ensures that your network and systems are continually assessed for new vulnerabilities, maintaining a robust security posture. When discussing the placement and configuration of virtual private networks, or VPNs, it's essential to understand their primary function. VPNs are crucial for securing data transmission between remote users and private networks. This is achieved by creating a secure and encrypted connection over a less secure network, typically the internet. There are two main types of VPNs. The first is site-to-site VPN, which connects entire networks to each other, making it appear as though they are part of the same local network, even if they are geographically distant. The second type is remote access VPN, which allows individual users to connect to a private network remotely. This is particularly useful for remote workers who need to access company resources securely from various locations. An example command to start a VPN connection using OpenVPN is openvpn-config client.ovpn. This command uses a configuration file, client.ovpn, to establish a secure connection to the VPN server, ensuring data transmitted between the client and network is encrypted and protected. Understanding these components and their configurations helps maintain a secure and efficient network infrastructure, particularly in today's increasingly remote work environment. On this slide, we're focusing on network access control, or NAC. The main function of NAC is to control devices' access to network resources based on specific policies. This ensures that only authorized devices and users can access the network, adding an extra layer of security. In terms of deployment, NAC typically involves user authentication and health checks before granting access. This means that before a device can connect to the network, it must authenticate, often through credentials, and pass certain health checks, such as ensuring the device has updated antivirus software. An example command for implementing NAC could be bash sudo hgors-auth policy file policy.json. This command applies a specific policy file, nappolicy.json, to manage the authentication and health check processes for the users and their devices. On this slide, we will be discussing the component placement and configuration of a web application firewall, or WAF. The primary function of a WAF is to protect web applications by filtering and monitoring HTTP traffic. This helps in preventing various web-based attacks such as SQL injection, cross-site scripting, and other threats that could compromise the security of the web application. In terms of deployment, a WAF is positioned between the client and the web server. This intermediary placement allows the WAF to inspect incoming requests and outgoing responses, ensuring that malicious traffic is intercepted before it can reach the web server. Some example tools you can use for WAF implementation include ModSecurity and AWS WAF. These tools provide robust filtering and monitoring capabilities that can be configured according to your security needs. Furthermore, if you are using ModSecurity with an Apache web server, the installation can be done using the following commands: sudo apt-get install libapache2-modsecurity sudo a2 nmod security2. Executing the first command will install the ModSecurity module, and the second command will enable it on your Apache server. Setting up these tools will help you enhance the security posture of your web applications substantially.
Continuing with our discussion on component placement and configuration, let's dive into proxies and reverse proxies. A proxy server forwards client requests to another server, effectively hiding the client's identity from the destination server. This adds a layer of privacy and security for the client's interactions over the internet. On the other hand, a reverse proxy operates a bit differently. It forwards requests from clients to backend servers, and in the process, also performs load balancing. This ensures that the incoming traffic is efficiently distributed across multiple servers, enhancing the performance and reliability of the server setup. Two popular tools used in these configurations are Squid for proxy services and NNX for reverse proxy functionalities. Each of these tools serves a critical role in optimizing and securing network traffic in various server environments. Understanding the distinct functions of proxy and reverse proxy servers and how to effectively implement them with tools like Squid and Nginx will greatly enhance your ability to manage and secure web traffic. Let's move forward to explore their configurations in more detail. Let's dive into another vital aspect of component placement and configuration, the API gateway. An API gateway is fundamental in managing, securing, and routing API traffic within your system. This component acts as an entry point for client requests directed towards microservices, offering a layer of abstraction and facilitating the enforcement of policies such as rate limiting, authentication, and logging. When it comes to common tools, you have excellent options like Kong and Tyke. Each of these tools provides robust features to handle your API management needs efficiently. For instance, with Kong, you can easily define routes to manage how traffic is directed. As an example command, using Kong, you can add a route with shell Kong routes add name equals my route, paths equals my path. This command helps you create a structured pathway for your traffic, ensuring that requests are properly managed and directed to the correct backend service. Understanding and utilizing an API gateway is critical for maintaining efficient and secure communication between clients and your microservices.
In this slide, we'll explore the concepts of taps and collectors within our component placement and configuration discussion. Starting with network taps, their primary function is to provide a method for accessing and monitoring network data without causing any disruption to the network traffic. This functionality is crucial for situations where data integrity and uninterrupted service are paramount. On the other hand, collectors serve a different but complementary role. They aggregate data from multiple network points, which is essential for comprehensive analysis. By gathering data from various sources, collectors enable a more complete view of the network's status and potential issues. A common tool used for these purposes is Wireshark, especially for packet capture. Wireshark allows in-depth inspection of network traffic, making it a valuable resource for both network taps and collectors in troubleshooting and analysis. In summary, network taps and collectors are integral for effective network monitoring and analysis, enabling access to real-time data and comprehensive data aggregation for deeper insight into network performance. When it comes to content delivery in our network, a content delivery network, or CDN, plays a crucial role. The primary function of a CDN is to distribute content to end users with high availability and optimized performance. This means that your website's data can be delivered quickly and reliably, no matter where the end user is located. The benefits of using a CDN are significant. Firstly, it reduces latency, which is the delay before a transfer of data begins following an instruction. This is achieved by storing cached versions of your content in multiple locations around the world, so the data doesn't have to travel as far to reach the user. Secondly, CDNs enhance security through their distributed architecture. By spreading content across many servers, it becomes much more difficult for potential attackers to disrupt service or degrade performance through attacks. Examples of popular CDN providers include Cloudflare and Akamai. These providers offer robust solutions that not only improve speed and reliability, but also add layers of security to protect your data and your users. Understanding the function and benefits of a CDN is essential for anyone involved in network configuration and security. By effectively utilizing CDNs, you can significantly enhance your network's performance and security measures.
In this conclusion, we've summarized essential points about strategically placing and configuring your security components. It's crucial to understand the diverse roles they play in maintaining an effective security posture. Balancing security and performance is vital for achieving optimal results. As we move forward, we'll dive deeper into the specific settings and configurations of individual components. For additional reading and resources to deepen your understanding of the topics we've covered, here are some valuable references. Firstly, the Nessus documentation, which provides comprehensive guidance on using Nessus, a widely used vulnerability scanner. For those working with secure communication, the OpenVPN How-To is a practical resource for setting up and managing VPNs. The Mod Security Reference Manual offers detailed insights into configuring this open-source web application firewall, enhancing your web security knowledge. Additionally, I recommend Network Security Essentials by William Stallings. This book covers fundamental concepts and practices in network security, providing a solid foundation to build upon. These resources will equip you with the tools and knowledge to further explore and refine your security configurations. Thank you for your attention and engagement throughout the course. If you found the content helpful or insightful, please leave a like to show your support. Feel free to comment below with any feedback or questions you may have. Don't forget to subscribe to stay updated with more valuable content. Also, sharing this course with your friends and colleagues can help them benefit as well. Your continued support helps us create more high-quality learning materials. Thank you.